Hello there. Welcome to Have Your Serverless Kotlin Functions and Eat Them Too. My name is Andrew. I'm from Canada. The nice thing about the jet lag is that I've been waking up right on time for the hotel breakfast. And this morning, I actually saw that they had some Canadian maple syrup, 100%. That's liquid gold in Canada. We're actually having a bit of a problem right now where our maple syrup reserves are at an all-time critical low. It's devastating. But anyways, so a few things to note before we really get started here. There is a lot of code. I'm not actually going to be showing most of it, though. There is a lot of data to be shown. I'm going to be showing graphs. The raw data is available, though. And there's also going to be quite a few tutorials linked throughout. So we're going over a lot of content here. And so the best way to get all this stuff isn't necessarily taking photos of every slides. Everything is on the talk website. So andrewohara.dev/cake, or you can take a picture of the QR code. And if you're too slow or you want to reserve judgments for the end, the link will be at the end for you as well. Now, the final thing is, even though the title of this slide is Serverless Functions, which implies more than just the existence of AWS Lambda, I know there are other competitors out there like Azure and GCP. I am an AWS fanatic, so all of the examples here are for AWS Lambda, and there are some things that are specific to it, but I did try to make things as platform agnostic as possible. So, with that out of the way, let's get started. So, if you're here, you probably are interested in serverless or have tried it and failed when you notice that my apps aren't really performing so well. So I'm not going to go over why you might want to do it. But if you are, it kind of makes sense that you're going to want to bring everyone's favorite language. So if you're here, Kotlin's probably one of, if not the most favorite language in your arsenal. And so, of course, you're going to want to bring it everywhere you work. But there is a problem, and its name is cold starts. That's what this talk is about. You'll notice that when you deploy your function, you're sitting there, well, you deploy your function, you run it, and you're sitting there wondering, why is it taking so long to get a response back? And that's because of the cold start. So serverless isn't the lack of existence of servers. It just means you're not managing the servers. When you run your app, it is behind the scenes being deployed to a container right after you invoke it. And that takes time. And with the JVM, regardless of whether you're using Java, Kotlin, Scala, Groovy, that takes even longer, unfortunately. That is the problem here. And it doesn't just happen the first time. You think, okay, 5,000 milliseconds, that sucks. But you refresh again, and it's much faster. And it'll be like this for a while, until you start getting multiple requests coming in at the same time. Or Lambda just felt like terminating your app. Or you've deployed it again. And this is going to keep on happening. And if you are depending on these responses to come back in a reasonable amount of time, you're going to have a bad time. Now, if you're running workers, like they're getting events from a database table, or they're handling queues, it's not really a big deal. You just want it done eventually. And so we don't really care too much if it takes 5 seconds for your function to start up. But on the other hand, if you have an HTTP API, where you have a user on a web application, and they click a button, you don't want it taking 5 seconds. The golden rule is like 100 milliseconds. 5 seconds is what? 5,500 times? I can't do math. That's what calculators are for. Anyways, yeah, so response time is absolutely critical here. And so if we want to use our favorite language in these contexts, we need to come up with a way to make it drastically faster. Now, you may have heard some of this advice before. Lazily load your app. But Serverless is for microservices. Chances are, if you have requests coming in, you're going to need most, if not all, of those components anyway, so lazily loading doesn't do anything for you. You might have heard to do scheduled warming. So have something on a timer that's calling your function every now and then, and it will ensure that you have at least one. But the problem is, you can't guarantee that your schedule is going to be the one to incur that cold start. It's a race between it and the user, and so it's not so great. Now, if you're on AWS Lambda, you have another option, provision concurrency. It's pretty great. It actually does guarantee that you're going to have some number of containers ready to go immediately. But you have to pay for this. And so if you're under provisioning, if you have a spike in traffic or traffic just increases over time, you're going to start hitting these cold starts again. And if you're over provisioning, then you're overpaying. And we all know that Lambda can start to get pretty expensive sometimes. So we want to avoid that. These solutions can help, but they're not the solution. So we're here because we want to have our cake and eat it too. We want to have our serverless Kotlin functions that are fast and don't cost everything. So that's what we're here for. That is what I am going to teach you how to do, to have your cake and eat it too. Now to start off here, we're going to have a bit of a face-off where we're going to look at all of our favorite stacks that we use in Kotlin. Some of them are Kotlin, some of them are Java that we can still use with Kotlin, but we can eliminate a bunch of them right off the bat. It's always my preference that if I'm going to be deploying a serverless application, I don't want to be writing all this glue code to get it to work. I want just a drop-in adapter, and half of these, unfortunately, do not have it. So that leaves us with Micronaut, HTTP4K, Spring, and Quarkus. So let's take a closer look at those. I'm going to come up with a fairly simple microservice. It's an API managing posts in a publication or Reddit or something like that. Has a few endpoints. And to level the playing field, we're going to be always using one of the official AWS SDKs for DynamoDB. We're always going to be using Jackson for our JSON. And they're all going to have 2 gigs of RAM to run on AWS Lambda. Now, I built this app in each of these 4 stacks. I'm getting jar sizes anywhere between 21 to 31 megabytes, which isn't bad. So let's see how they perform. I performed a series of experiments, measuring the cold starts each time, came up with some averages, and I got this. Is anyone surprised? Yeah, like Spring, it has a purpose. Its purpose is not serverless. It is optimized to take a long time to start up, and once it's started up, it's going to run great. But that's not our goal here. Our goal is to start up as fast as possible, and so of course Spring is going to be way up there. Not an option. Now, we might look at the rest of our results and say, oh, okay, Micronaut, that's the winner here. But it's not that simple because it's going to depend on what you're doing with it and how the space weather is feeling at that day. And so we can say that Quarkus, HTTP4K, and Micronaut are comparable. But they're still not good enough. Like if I don't want to wait 5 seconds, I probably don't want to wait 2 or 3 either. So this isn't going to be, like, there's no clear winner here. We need something else. So getting back to AWS Lambda here, they have another solution beyond provision concurrency. It's called SnapStart. And the way that it works is, when you deploy your application, it runs a cold start just once. Saves a snapshot of that in memory. And then, when you invoke your function, if it needs to start up a new container, rather than doing the cold start all over again, it's going to restore that snapshot. It's ready to go. And this is going to be a lot faster. Now, it's fairly simple to enable this. I'm using AWS SAM here. And all you really need to do is start publishing versions of your application and then configure SnapStart to use them. And we get these results. So look at this, Spring. a little bit of a comeback here. Surprised me too. But it makes sense, because we know that Spring takes a lot of time to start up, but it already did that back before the snapshot. And so it is finally competitive. So Spring lovers rejoice. It's definitely a lot better. Quarkus, HTTP4K, and Micronaut are still better, but it's not night and day anymore. It's still pretty comparable. But, well, depending on your performance requirements, you could just say, I'm happy with this. Like 600, 800 milliseconds, that's a heck of a lot better than 5. And that's okay. You could stop here. But there are some limitations. So beyond the fact that this is just on AWS Lambda, there's some other problems. If you're doing stuff with the file system, doesn't support elastic file system, doesn't support disk sizes above 500 megs. And the fact that there's restore has its own class of problems, where we've taken a single snapshot, that's a single state, single random seed. Now, if you're using secure random on the JVM, it's not so much of an issue because it works past this. But where security isn't a huge factor, you might want to use just regular random. And that does have a static seed. So all of a sudden, you're going to have however many instances of the app all generating the same random numbers over again, which isn't great. So you're going to need to come up with a way to reestablish entropy, as they call it. And if you made any connections to databases or whatever, they're going to be gone. And normally in Lambda, you can just get the credentials from the environment. But in this case, like the credentials need to expire. They can't be baked into the image. And so you need to go and ask AWS for them. And that kind of eats into our gains that we made by making the snapshot. Now there is a tool. It's called Java Coordinated Restore After Checkpoint. It's not just for Lambda. You can also use it in Docker containers. And this thing gives you a hook where it's going to call you during the restore. And so you can do all these things that you need to reestablish entropy just the once and not every single time your function is invoked. So that's better. And performance-wise, if you are a fan of using Gravitron, well, you're out of luck here. You have to use x86. It also doesn't support provision concurrency at all, so you can't combine advantages. Here. So you better be okay with this being your typical worst-case scenario. So there's another option, GraalVM. Now, originally when I wrote the abstract for this talk, I'm like, no, I don't want to use GraalVM. It's so complicated, but I really wanted to be complete here, and I learned a lot in the process here. So basically, Graal is compiled Java, where you might say, what are you talking about? I'm compiling to a jar. Well, it's not quite that simple, because even though you have a jar, it's not machine code. It still needs to be recompiled when it actually runs. And so if we do all this compilation ahead of time, we're obviously going to get a much better startup. And because we no longer rely on the JVM being present, we're running on bare Linux containers. So even though our zip file might be larger than a jar, overall the container that we're running is smaller, so that's going to be faster. It's also cloud agnostic. This will work on in pretty much any cloud that supports a custom runtime for your serverless functions. But there are still challenges, the same challenges that made me very nervous about trying this. It requires a custom runtime. So your apps that you design for running on the JVM, the harness, aren't going to work anymore. It doesn't really like reflection, doesn't really like a lot of libraries, and it requires you to have a native toolchain installed, which can be a little bit difficult. But these challenges can be overcome. It just kind of depends on what stack you're using. So Spring, notorious for having very long startups, but it has a plugin called AOT, ahead of time, where it's going to do all the startup ahead of time and compile it to a Graal binary. This is pretty awesome, but the problem is it doesn't really seem to be compatible with its serverless support. And so someone can correct me if I'm wrong. There may be ways to work around it, but I don't care enough about Spring to do that. So this is going to be eliminated, unfortunately. Quarkus. Quarkus was designed, I don't know about initially, but it was designed at some point to be very compatible with Graal. That's great. It has a Gradle plugin, which is going to handle the Graal generation for you. It even will run it in a Docker image, so you don't have to have Graal installed. You don't have to have Windows C++ compiler, whatever you do on Mac. It can handle it for you. That's pretty nice. Micronaut, pretty much the same thing, except small little limitation I discovered. If you're using if you're coming up with an HTTP application, it doesn't seem to support the modern HTTP API gateway on Lambda. It only works with the legacy REST one for some reason. So be aware of that. It was very confusing when I tried to get it to work. Now, HTTP4K. Unlike the rest of these stacks, it is not a framework. It does not have a Gradle plugin. It's not going to hold your hand, but it will show you the way. It does have instructions. It can even do it in Docker. It does ship a custom runtime that you'll need to run your Lambda. And because the core library doesn't even use reflection at all, we don't have to worry about those library limitations of Graal. So not bad. So once I've made these changes and I've tested everything, this is what I get. Interestingly, Micronaut didn't really benefit. I'm guessing that's kind of because Micronaut tries very hard to do as much ahead of time as possible. So perhaps there aren't as many benefits we can gain from here. However, Quarkus and HTTP4K do get some fairly incremental improvements beyond what you can get with SnapStart. So that's interesting. Is anyone here good with 450 milliseconds? Raise your hand. Oh, really? Oh, wow. Okay. Well, that's good, because we can still do better. Whew. Now, SnapStart. Kind of gives us mediocre performance, has some issues. Graal, fairly decent. And yeah, none of you are still good with 450 milliseconds, so yeah, good thing we have another option. But it's even more difficult to get working. So what's our third option here? It's actually optimizing our application. Shocker. Now, there's 3 ways we can do this. Minimizing the init. So that's basically getting rid of all the computation, so all the spring reflection that happens, get rid of it. Getting rid of external calls to get secrets. Much better to embed those into the environments. Now, I don't actually really know if that's secure, but I do it. or you just use something like AWS, what's it called again, KMS at runtime. That works too. You also want to have a smaller artifact. So that means fewer dependencies, lighter dependencies. Now, if you're using a framework, that's kind of difficult because it chooses everything you're going to be using. Minimizing reflection. I know reflection is our friend. Some of us love to hate it, but you can't deny how useful it is. But it's fairly slow. Like, on a beefy machine, it's not really all that noticeable, but when you're starting up on these constrained environments, it is a huge problem sometimes. So we want to prefer using static mappings. Like if you were in Daniel's talk this morning, what JSON library to use? Silly, just do a string format. Sure, you can do that. Or you can use code generation to handle most of the heavy lifting for you. So we are going to optimize our HTTP4K application. And it's not just because they're holding me hostage right there. It's not just because I'm a good friend of the HTTP4K community. It's because I actually think it's perfect for serverless, and there's a couple reasons. If we look at our 3 pillars that we want for a faster application here, we want less init. So because HTTP4K isn't a framework, you don't need a whole other application just to run your application. It does what you tell it to do, and only what you tell it to do. So you have much greater control over how long this init is going to be. We want a smaller artifact. Well, the core module, it's only 1 megabyte. Has no dependencies, unlike some other I can think of. I really don't like Spring. We want less reflection. Well, guess what? The core module uses none of it. It's only going to do what you bring in. So if you're using Jackson, well, can't help you there. Don't really like that one so much too, but I still use it a lot. There's another reason. What is serverless? Well, it's functions. What is HTTP4K? Well, it's the functional HTTP server. HTTP4K, at its very core level, is a function that takes a request and returns a response. That's literally what it is. Type alias function equals request to response. Lambda is the same thing. It's a serverless function that takes some sort of payload, in this case, a JSON representation of an HTTP request, and returns a JSON representation of an HTTP response. And so the adapter that you need to get HTTP4K to work on serverless is very tiny, very simple, nothing can go wrong, end quote. So, there's a couple things we can do to improve our application here. I put everything on a level playing field, to be fair, but we are in the best possible case. We're set up for the best possible success here. The first thing we can try is to optimize the V2 AWS SDK. Now, AWS themselves actually publishes instructions for doing this. So that link is where I learned how to do this. We're going to start off with the enhanced DynamoDB SDK, which has some additional challenges because it's using reflection to map the Dynamo documents into your data classes. No beans allowed. But it is fairly bloated. It has the Apache HTTP client, which is fairly notorious for being big. There's Netty, which is a little less big, but you definitely don't need both of them. And we probably don't really want any of them to start with. There's a much lighter option we can use. So after we exclude them from Gradle, we need to get our replacements. So the AWS SDK publishes an alternate client, and it's just a wrapper around the one that's built into Java 8. Hands up if you're still using Java 8. Oh, okay, I'm good. Okay, 1, 2, 3, 4 or so, do better, but the rest of you, I'm pretty happy for you. But it has this thing called the HTTPS URL connection. And it kind of sucks to use yourself, but AWS already did the hard work of actually making a useful client out of it. So we're going to bring that in, and we can configure our Dynamo SDK to use it. So it requires a little bit of extra work. You can't just use client.create. You have to actually bring in the builder. The final thing is we can overload the credentials provider. So by default, the SDK is going to look in like 6 places or something, several places. And one of those may have the credentials it's looking for. Oh, I missed my chance for a droid joke. Gosh. Anyways, to bypass this, to save all the time it's going to take to do this, you can just pass in the credentials provider or even the credentials that you want to use, saving some time. Now, let's see how this works. We saved, what's that, 150 milliseconds? We started with 2300? That kind of sucks. Like, look how much space we saved on our jar. Like, we eliminated 5 megabytes, but we're only getting 150 milliseconds. Like, if this was the last thing in the way, if you went from like 600 to 400, no, wait, no, you guys already said 400 is not good enough. So if you were going from like 400 to 250, maybe that's pretty good. But 2300 to 2100? No, we need to do better. Don't be sorry, be better. Anyone like the God of War series? Really? Gosh. Okay, so there is an alternative client, an alternative SDK we can use, and it's published by HTTP4K Connect. And it's not just because they're holding me hostage still. The reason why we really want to use it here is because it synergizes. It's using the same core module. So we're eliminating so much space by taking away the DynamoDB SDK from AWS, and we're not really replacing it with much else, so we're getting a smaller jar. So once we bring this in, we need to redefine our repository. But there is, you see that thing that's in the yellow? Like, because we're using the optional mapping module, where we're taking our documents and we're using reflection maybe to convert it into our data class, because we don't like beans, we need JSON support. So we need to pass it in. Why are we passing it in? Well, because HTTP4K Connect, by default, has actually generated all of its JSON adapters ahead of time. That's the other reason why it's really fast. But it doesn't know how to do our, what's something really tedious I can think of? Quarterly report statements, yeah. Doesn't know how to map that. Okay, in this case, we're doing posts, much more interesting. So that's why we need random JSON support. But we'll get back to this. There's more we can do. The other thing you want to do, so the default settings are pretty great normally, but the default settings here are using the Java 11 HTTP clients. Hands up if you're using Java 11. Yeah, good. Yeah, Java 11 is pretty old too. I think it's out of date now. So only a few people in the Stone Age still, but it has a much better HTTP client, much easier to use than Java 11. Sorry, much easier to use than the HTTPS URL connection. So it's no surprise that it's the default here. But the problem is the Java 11 client is creating a connection pool, and this takes time. We have no time. So we are going to replace it with the Java 8 HTTP clients that the HTTP4K guys were so kind to slave over. I can't imagine how fun it would have been to make that. So that's what we can do. Now, this is where we get our first incredible improvements. Almost half the response time. Hands up if you're okay with the 1300 millisecond cold start. Really? Gosh, tough crowd. Whew. Okay, so clearly we still need to do better. But there's 1, 2, 3 more steps. So let's see if I can impress you guys. So I alluded to that we need to eliminate our reflective JSON. Well, this is where we're going to do that. Right now, we're using Jackson and Kotlin Reflect. Together, they're over 5 megabytes in space. That's quite a lot. It's also not even really that fast. Like in a huge app, like that's running on a huge server, we don't really notice. But we're on a resource-constrained environment here. We want things now, not in 1500 milliseconds. So we want to eliminate that reflective step. But since we noticed that HTTP4K Connect is already using reflectionless JSON, we can try to copy their homework to come up with another way that isn't string formatting, as Daniel mentioned earlier. Like, that's pretty tedious. So how does HTTP4K Connect do this? Well, it's using a plugin for Moshi. So Moshi is already a fairly light JSON mapper, but it still uses Kotlin Reflect, which is its worst quality, but it really doesn't have any better option. And so with this Kochi plugin, hands up if you've used or heard of KSP or capped. Okay, yeah, all right. Look, a fair number of you, but KSP or capped, they're, I don't know if it's correct to say that they're code generation plugins, but they're plugins that can generate code for you. Now, Kochi is leveraging on this to generate our JSON adapters. And so there's no reflection required. It's all just code that's being executed. So that's pretty good. So how do we do this? Well, it's a fairly complicated process. I'm going to try to show you the high levels here, but there is another link that you can follow if you've gotten the slides. We need to import the annotations that we need. We need to configure KSP to generate the code for us. We need to add our fancy annotations on our data classes to tell Kochi that we're going to be generating adapters for them. We also need a JSON adapter factory and add another annotation. And then because we're using HTTP4K here, there's a bit of an extra step to integrate it into the library. So we're coming up with a configurable Moshi and adding our JSON adapter factory to that chain. And once we have that, we can start using it to convert our posts into JSON without reflection. And we can replace the Jackson that we injected into our post repository with this instance. And so now, even to map our DynamoDB documents into our data classes, because we don't use beans, it is reflectionless. So this gives us a fairly modest improvement, honestly. Still better than nothing. But good thing we've got 2 more things we can try. Next is the logger. Might be using log4j too. And I was kind of surprised to learn that it's actually 2 megabytes, which doesn't really sound like much, but considering we're at 7 megabytes, we can eliminate a good chunk of our jar. And log4j may be great, but it's a little advanced for what we're trying to do here. We can probably get away with something much simpler, like Java util logging, or in this case, SLF4j simple. So it requires a very simple configuration that you can put right in your resources directory, and it's going to shave off 2 megabytes. So I was actually kind of surprised how much of an improvement this made here. Now, okay, none of you raised your hands about 450 milliseconds, so I don't expect you to raise your hands for 600, but that's still pretty good, and that's not even using snap start. This is a pure cold start. It's not bad, but there is still one more step we can take. We can choose Graal. Now, like I mentioned earlier, HTTP4K Connect does show you the way how to do it. It comes with the custom runtime, which we can import, and we need to write a main function. We're no longer using the existing Lambda handler interface. We can't do that anymore because we need a custom runtime. So we write a main function that's going to start this custom runtime for us. Now, the next step is we actually need to configure Lambda to run our custom runtime rather than a Java container. So we're switching to Amazon Linux 2. We're not using a handler anymore, that's why it says unused, and we're plugging in the zip rather than our jar file. Now this gets us down to 268 milliseconds cold start. Hands up if you're okay with that. Okay, yeah, lots more. Okay, haven't really convinced a good number of you, which I'm a little surprised about. Like, come on, this is the worst case scenario, not your typical scenario. But okay, tough crowd, fair enough. So this is where we land now. We can see that after we've optimized our HTTP4K application, the cold start rivals the snap start that we had before. The snap start rivals the Graal start we had before. And even better yet, our Graal start is in a class on its own. 268 milliseconds, down from 2,300. That's insane. So, for roughly half you, I think, that is how you have your cake and eat it too. If 250 milliseconds isn't good enough for you, I don't know what is, so so I guess I'm not going to convince you. But my goal here is to get at least some of you trying to use Lambda or serverless again. And so hopefully I've convinced some of you. We've got 3 different options here. If we're on Lambda, we can use snap start. Anywhere else, or if we want better performance, we can use Graal. But even better, if we optimize our application, we can synergize with Graal or snap start. And so this is how we've gotten down from 5,000 or 2,000 milliseconds down to 250. Massive improvements. So I hope that this has inspired you to try it on your own. Let me know what results you get, whether you're happy with that. If you're not using snap start, you can still combine it with provision concurrency, so you can get kind of the best of both worlds. And that, for half of you, I guess, is how you have your cake and eat it too. So, like I mentioned before, if you want to find out more about the example code, the raw data, or find the tutorials, you can go to andrewhara.dev/cake. I also like to write about this, make videos about serverless, DynamoDB, or just testable applications. So if you'd like to see more of this, you can also check out just my regular website. And The people down there, they reminded me to tell you, make sure that you vote for talks. This is my first talk, and I'd love to come back again, so thumbs up, please. And thank you very much.